Final problem, final example for the difference of squares rule. 16x to the fourth minus 81. Again, we first check for a greatest common factor, but there does not exist a common factor between 16 and 81. So I'm going to see if this will fit my difference of squares rule. Well, 16 is a perfect square because 4 squared equals 16. X to the fourth is a perfect square because x squared squared is x to the fourth. And 81 is a perfect square because 9 squared is 81. So we know that this 16x to the fourth minus 81 will fit my rule. And the answer is going to be 4x squared minus 9 times 4x squared plus 9. Now before I get myself all in a hurry here and say that my problem is complete, I need to check my parentheses to make sure that the rule doesn't apply again. Well, as I look, 4x squared minus 9, 4 is a perfect square, x squared is a perfect square, and so is the 9. I also have the minus sign that's required for the difference of squares rule. So that means that this particular thing can continue. So I'm going to factor out that 4x squared minus 9 using my greatest common factor, my difference of squares rule. So that will factor to 2x minus 3, 2x plus 3, while the 4x squared plus 9, it's exactly the same as the other term except for the plus sign. There is no sum of squares formula. This is a prime binomial. We cannot factor that. So that stays the same. That stays 4x squared plus 9. Now a common mistake would be to leave that 4x squared plus 9 away from our final solution, but it's the entire quantity that is our final full factorization of 16x to the fourth minus 81. So watch out for multiple applications of rules in your factoring problems.